on senior intermediate today, and the topic for that is going to be probability and combinatorics. And in that, we're going to cover probability and combinatorics, complementary counting, and at least one. Our first topic of today is probability and combinatorics. Sometimes we need to have combinatorics and probability together because sometimes in probability you need to use counting to find the number of total ways and the number of favorable ways. You can't just write them all out. Sometimes there's too much. For example, let's say we have a group of 12 students and 3 of them are selected for a group. And we want to find the probability of Tom being selected but not Jerry. So to do this, let's first try to find the total number of ways we can do this. So we do 12 choose 3. There are 12 people. We're choosing 3 of them. And since we're not ordering them, we're just putting them into a group. It's combinations and not permutations. We have 220 total ways we can do this. And then after we select Tom, we have 2 more spaces we can fill. But we only have 10 options for those 2 spaces because we can't have Jerry and we can't already have Tom because we've already selected him. So we're going to do 10 choose 2. Once again, it's combinations because we're making a group and we're not ordering them, and it's 45 wanted. So we're going to do our normal probability formula, favorable over total. We do 45 over 220, which simplifies to 9 over 44. So now let's move on to our second topic, which is complementary counting. And basically, it's that complementary counting is what we use when there are more ways not to do a certain event than to actually do it. That might have been a bit confusing, so here's an example. Let's say we have an event, me catching the tennis ball. The complement of me catching the tennis ball is me dropping the tennis ball. Those 2 events are complements because those are the only 2 things that can happen. So let's go over some notation. P of A is a probability of event A. P of A prime is a probability of A's complement, or that can be inverse. And one thing that you notice about the 2 is when you add these 2 up, you get 1. Because all the probabilities of an event added up equal 1. Because it has to happen. And yeah. So our last topic of today is at least 1. And basically, we're going to do this because a problem is going to ask you, what is the probability of at least one thing happening? And you're going to take forever to do it because if you do the probability of at least one thing happening, 2 things happening, 3 things happening. And here's the simple solution. Just calculate the probability of none of it happening. So basically, the complement of at least 1 is none. So you subtract the probability from 1, and there's your answer. So let's try doing that in an example. Our question is, what is the probability of selecting a random 4-digit number without the digits 2 or 3? So let's first find the number of total 4-digit numbers. Remember from counting how we subtracted the 2 numbers and added 1 because you wanted to include one of the numbers? Well, this is what we're going to do. 9,999 minus 1,000 plus 1. We need that 1 or else we're going to forget either one of these numbers. And they're still 4-digit numbers, so that's going to mess up our problem. And we get 9,000 total numbers. And now let's find the number of favorable. Let's start with our first digit. Our first digit can't be 2 or 3 or 0. If it's 0, it's not a 4-digit number. If it's 2 or 3, then it's not what we're trying to find. So we have 7, and then for the rest of our digits, we all have 8 because there's 10 total digits and it just can't be 2 or 3. 10 minus 2 is 8. And multiplying this out we have 3,584. So the probability of 9 is 3,584 over 9,000. But we don't want that. We want the probability of at least 1. So we're going to do 1 minus 3,584 divided by 9,000, which gives us 5,416 over 9,000. Simplifying, we get 677 over 1,125.
Hi, my name is Siddhi and I'm going to be solving problem for part 2 of probability and combinatorics. Ryan flips a coin 4 times. What is the probability that he flips heads at least 3 times? Express your answer as a common fraction. So the first step to this problem is finding the number of ways for flipping 3 heads and the number of ways for flipping 4 heads. So there will be 4 possible ways for 3 heads, and those possible ways are heads, 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 tails, heads, heads, tails, heads, and tails. Those are the 4 possible ways for flipping 3 heads. For flipping 4 heads, there's only one possible way, which is heads, 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 heads. Now to find the probability for this, there are 4 possible ways here and 1 here. So we're going to add them up together and get 5 and put that over the total number of possibilities, which is for each time we flip a coin there are 2 possible ways. So we're going to multiply 2 4 times because you're going to flip the coin 4 times and you're going to get 16. And 16 is the total number of ways. So we'll put it over 16 and this is the probability. The next problem is an integer from 1,000 to 9,999 inclusive is chosen at random. What is the probability that it is an odd integer whose digits are distinct? So the first step to finding this problem is finding how many integers there are from 1,000 to 9,999. So to do that, you have to subtract 9,999 and 1,000. But then you have to add 1 back because it is inclusive, and since you took one number out, you have to add it back in. When this is done, you'll get 9,000. Then, since the round is 4 digits, we have to find the last digit, first digit, second digit, and third digit. So to find the last digit, it has to be any odd number. So there are going to be 5 possibilities because the number has to be odd. Those possibilities are 1, 3, 5, 7, and 9. For the first digit, there can only be 8 possibilities. And that is because the first digit cannot be 0 because then it won't be a 4-digit number. And it cannot be one of these numbers because each number has to be distinct. For the second digit, it will also be 8 because the number can be 0, but it cannot be one of these 2 numbers. So there will only be 8 possibilities. For the third digit, there will only be 7 possibilities because the digit cannot be one of these 3 digits. So after you've done this, you would have to multiply 7, 8, and 5. And then you have to put it over 9,000 because it is the total number. When this is done, you will get a total of 56 over 225. The next problem is 2 spinners are spun once and each land in one of the numbered sectors. What is the possibility that the sum of the numbers in 2 sectors is a prime? So in order to do this, we have to add up the possibilities for all the sectors. So first we're going to do 1 plus 2, 1 plus 6, and 1 plus 4. Then we're going to do 5 plus 2, 5 plus 6, and 5 plus 4. Then we have to do it for the last set, which is 3 plus 2, 3 plus 6, 3 plus 4. Now you want to go ahead and add them all up. After this, you have to circle all the sums that are prime because we want to find the possibility of the sum of the numbers that are prime. So 3, 7, 5, 7, 11, 5, and 7. Now that we've circled all the prime numbers, we're going to count them all up. When we count them all up, we get 7. Put that over the total number of possibilities, which is 9, and that is our possibility.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramathcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email, but without the info and the end. So bye!